In today's lesson, we're going to look at factoring trinomials without a coefficient. So let's get started. To review, we're going to practice multiplying these two binomials because this is going to tie into how we will factor trinomials. Remember that factoring allows us to basically work backwards. When we're factoring polynomials, we will start with a polynomial, something like that, and we will work backwards to end with two binomials being multiplied by each other, or just a set of monomials, binomials, and even maybe polynomials that have been broken down as factors, meaning that when you multiply them back together, you can get back to the polynomial you started with. This will ultimately help us solve higher exponent equations. So for the beginning, or for this unit, we're going to focus mostly on the methods for factoring so that when we get to equations where we're solving with variables that have exponents of 2 or 3 or 4 on the variables, we will be able to use these methods to help us find the value or values for x. So let's begin with this review. If we were to multiply these two binomials together, you would start by multiplying the x's by each other to get x times x is x squared. X times 6 is positive 6x. Negative 3 times x is a minus 3x. And negative 3 times 6 is negative 18. So here we are stretched out. If we had multiplied those two binomials out, this is what it should look like. I want you to notice that there is a special relationship between these values we get in the middle. First, they're both x to the first powers, okay? But they do have a relationship. The 6 and the negative 3 both have a sum of 3. That's going to be important when we're factoring. They also have a product of negative 18. 6 and 3 come from the original binomials. So if we can see that 6 and 3 should add up, when we simplify this, this will be a 3x, should add up to be a 3, but multiply to be an 18. And if we use that observation, we're going to be able to hopefully recognize the pieces we need to factor. And do also notice that once we simplify, the multiplication of these two binomials together ends up being a trinomial. So today we're going to work on starting here at this trinomial and going backwards, factoring the two binomials as factors that would multiply to give this as the product. So today we're going backwards. And if we know that a trinomial is the product of two binomials being multiplied together, then we're going to be able to set up a structure for factoring trinomials. Today's whole lesson is focusing on trinomials without a coefficient. So what that means is that when you see a trinomial, meaning three monomials in an expression, in your polynomial expression, there's three terms separated by addition and subtraction. The first one, or I should really say the one with the highest exponent, always has a coefficient of 1, meaning the number it's being multiplied by is a 1. So to factor a trinomial without a coefficient, you should immediately realize that it will factor into two binomials, as we saw with our warm-up. I want to give you a quick non-example of a trinomial without a coefficient. So if you saw something like 3x squared minus 5, oh, that's not a trinomial at all, sorry. Well, we'll say minus 5x plus 2. This is a trinomial, however, because the term with the highest exponent on the variable has a coefficient of something other than 1, that would not be a trinomial that we can use this method for. So we will learn those as we get further in our unit, but today we're focusing on the more basic trinomials where it's always a 1x squared or 1x to the fourth, whatever that highest degree term is. So If we recognize in this trinomial that x squared plus 8x plus 15 will definitely factor into two binomials, we can begin by giving ourselves the two binomial parentheses structure. So I call this like the skeleton. We're going to set up the skeleton of our factors. From here, remember that relationship we noticed about the middle term and the product of the last term. That's going to lead us to how we'll fill in the binomials. First, let's also focus though on the signs. Notice that it is a positive 8x and a positive 15. We're going to be filling in the pieces in the binomials. Binomials have either plus or minus here, right? And so we need to figure out, okay, if I were to multiply the first by the first by the last, second by the first, and second by the last, I should have the signs work out so that the last two multiplied together end up being a positive, and the middle two, when they're combined, end up being positive. So because all the signs are positive, that means our binomials will both have plus signs. As we get further in this method, you may choose to not fill in the signs until the end, until you find the appropriate factors for 15. Or like the numbers and how they'll work out. So you don't always have to do the signs right from the beginning if you're not exactly sure looking at it. But let's get to the numbers and filling those out. So what we need to do is find two factors that have a sum of 8. Remember, when we looked at the stretched out multiplication of those binomials, the two middle terms ended up adding to give us the middle term came from adding the -3 and the 6. Those are parts of our binomials. So we need to find a set of numbers that would add to 8. Now it can't just be any two numbers that add to 8. They need to have a special property where not only do they add to 8, have a sum of 8, but the two numbers also need to have a product of 15. So we need to look for two numbers that when we multiply them together, multiply to be 15. However, when we add them, add to be 8. So you could start a list of factors for 15, and I certainly would not expect you to make it this long fancy table for every possible factor that you're looking for. But this is a good place to start for us. So for looking at 15, we could do 1 times 15 to get 15. However, if we add those factors 1 and 15, 1 plus 15 is 16. Well, we need our 2 to have a sum of 8, the sum of the middle term. So this is not going to be a good option for us. So that's not our combination. Let's now look at another set of factors of 15. So 3 times 5 have a product of 15, which is good. And this time 3 plus 5, when I now add 3 and 5, that gives us a sum of 8 for the middle term that we were looking for. So this is the appropriate combination of factors that produce the product and sum that we're looking for. Once we identify that, we are going to fill in 3 and 5 in the second portions of our binomials. And it does not matter if you do 3 in the first one, 5 in the second, or 5 in the first one and 3 in the second. That will not matter, okay? Lastly, we need to figure out, how do we fill in this first piece? Well, it's important to think about what happens to get this part when we do go in the reverse direction and multiply out our binomials. So to get that original piece, remember, we started by multiplying the first thing in the first binomial by the first thing in the second. We always did x times x, in this case, to give x squared. So to go backwards and break it down, what we could do is take the square root of x squared, which is x, meaning that when I multiply this term by itself, it will produce this x squared we were looking for. So in this case, we do have an x squared. So if we take the square root of x squared, the square root of x squared is x, so that means I can fill x into the first slots of both binomials. And if I now multiply it back out, I will get x times x to be the x squared I was looking for, and go from there. Okay, so we filled in. The nice thing about factoring is you can always check your work. If you end with x plus 3 times x plus 5, and you're not confident that these are the correct factors for the trinomial you started out with, then go ahead and multiply it out. X times x is x squared. X times 5 is plus 5x. 3 times x is plus 3x. And 3 times 5 is plus 15. Our middle two terms did have that product of 15, and we want to confirm that they do add up to the 8x, which in this case, they do. So we have the correct binomials. All right, let's see. Is there anything else I wanted to say about that? Okay, so let's move on and practice some more of these. Oh, yeah. Never mind. Let's use our calculator. So to help us find factors, and it was pretty easy for 15. 15 has a pretty small factor list. That it was 1 and 15 or 3 and 5. However, we might be asked to find factors of 96 or 246 or something like that, which you may not know all the factors of in your head. So in this scenario, what we can do is use our calculator. Now I'm going to show you how to do this real quick so that you can use this as a tool anytime you're needing to find your list of factors. So let's say we didn't know which factors of 15 would add up to 8. What we could do is come over here to our calculator and go to your graph scratch pad. And so what we'll do is we'll always take the number we need the factors of, which should be the last term in your trinomial, in descending order. And we will graph a function where it's 15 over x. So here I am at my calculator, and I'm going to graph the function 15 divided by x. And I'm going to hit enter. And you should get something funky looking like this. If you don't see it at all, it doesn't mean it's wrong. It's possible that the graph was just off the screen, so your zoom is off. This really doesn't matter. Whatever shows up here, just kind of ignore it for now. Once you've done that, what we're going to do is pull up a table. And the way to do that is to type Control-T. And when you hit Control-T, this gives you a table of factors of 15. And the beauty of this is you can now scroll through and see here's one set of factors, 1 and 15, and you can just in your head add those up. 1 plus 15 is 16, so that's not going to give us the sum we need. And you can scroll down to find 3 and 5. You can also go in the other direction because sometimes we may need negative factors to see -1 and -15. -3 and -5, and so on. So we will use this as a tool from time to time when we need help finding factors. Don't be afraid to use it. Okay, with that being said, let's now practice another problem. So here we have a trinomial without a coefficient. Again, that means the first term has the highest exponent of 2, and there's an understood 1 in front of it. So this is a trinomial without a coefficient. So we know it will factor to 2 binomials. This time we need to figure out what would the signs of the factors need to be so that when we add our factors, they give us a negative value. And when we multiply the factors, they also give us a negative value. Well, if you think about factors multiplying to give a negative, it has to be one positive and one negative. There's no other way for us to multiply two numbers and it being negative unless one's positive and one's negative. So right there, you can fill in your signs as 1 plus and 1 minus. After you've done this, let's go ahead and find the factors of -20 that also have a sum of -1. And you know what? Let me give you a second to think about this and see if you can come up with the pair. Okay, So we want factors of negative 20. Those could look like 1 times negative 20, 2 times negative 10, or 4 times negative 5. It could also look like negative 1 times positive 20, negative 2 times positive 10, and negative 4 times positive 5. So you can see how quickly a list of factors can grow. From here, though, you need the combination of factors that add up to negative 1. So the set of factors that would add up to be negative 1 would be 4 and negative 5. So if you come through this list of factors that add up, this is the one we want. And again, if you weren't sure, you could go to that calculator and graph negative 20 over x and scroll through all the possible combinations of positive and negative factors and figure out which pair would add up to negative 1. So from here, let's fill the 5 has to be the negative. So in this case, it does matter where the 5 goes, and the 4 has to be positive because we need the middle term to have a sum of negative 1. Once we've done that, to fill out how we will fill this first slot is we'll take the square root of that highest degree term, our first term. And so in this case, that's b. So each slot gets a b. So we can check that by doing b times b will give us the b squared we're looking for. So our factors are b plus 4 times b minus 5. Again, you can multiply back out b squared minus 5b plus 4b minus 20. The middle two do combine to be negative 1b, so we are good to go. Here's one that I would like for you to try on your own. Notice this time, though, before you fill in or get too carried away, we need our two terms to have a factors of positive 25, but that add up to a negative 26. So when you're finding factors that multiply to be positive and add to be negative, that is a combination of factors that both have to be negative. So in your binomials, please fill in negatives here. Now find your factors of 25 and fill in. So click pause when you're ready to check, click play. Okay, so the factors of 25 that would add up to be negative 26 and have the correct signs would be negative 1 and negative 25. And square root of b squared is b. So we should have b minus 1 times b minus 25 as our binomials. I like to often set up a little factor tree off to the side. So for one like this, here t squared plus 16t plus 48, we need factors of 48 that are positive, or that multiply to be positive and add up to be positive. So that means that in your binomials, the signs are plus signs for both. And we need factors of 48 that would add to be 16. So you will see in a lot of the work I do with these factoring of trinomials that instead of making those elaborate factor tables, I will start by putting the 48 up top, kind of at the top of my tree, with this breakdown, the signs of them, and also jot down that they should add up to be a 16, a positive 16. So you want to think about your factors of 48. That would add to 16. I'll give you a moment to do that and finish factoring. When you're ready to check, click play. Okay, so you should have hopefully found that positive 4 and 12 would be the factors of 48 that would add up to 16. And the square root of t squared is t, meaning the first slots of both binomials should be t. When in doubt, or if you're not sure and want to check, go ahead and multiply that back out and make sure you end up getting this t squared plus 16t plus 48. Okay, here's our next example. So in this trinomial, we want to factor or find factors of negative 20 that multiply to be a negative and add to be a negative. Now remember, the only combination of signs that multiply to a negative are one positive and one negative, and they should equal negative 12. All right, so we're going to be adding one positive and one negative number that also multiply to be negative 20. So let's think of our factors of negative 20. The two that would add up to 12 would be some combination, most likely, of 10 and 2. However, if we try to make the 10 positive and the 2 negative, well, that adds up to be 8. If the 10's negative and the 2's positive, that adds up to be negative 8. So maybe it's not 10 and 2. You could try 4 and 5, but the 4 being negative, 5 being positive is just positive 1, and vice versa is negative 1. So that's not helping us either. If you come to a situation like this that does not have a combination of factors that work to multiply to be negative 20 and add up to be negative 12, even though you can find 10 and 2 if they were both positive to be positive 12, because one has to be negative, this trinomial does not factor. And if you'll remember, a number that only has factors of 1 in itself, like 11, is considered prime. So this trinomial is an example of a trinomial that is prime. So if you've exhausted your list, you've gone and you found factors of negative 20 in your calculator, and you've scrolled through, and there is just no way to get a set of factors that add up to be your middle term with all the signs correct, it is probably a prime polynomial, meaning that polynomial's only factors are 1 in itself. So you would just write prime and be done. All right, here's our next example. X squared plus 9x minus 10. We need one positive, one negative that add up to be negative 10. Take a moment, factor this one out. Let's check all together when you're ready. Okay. Hopefully you found the factors to be negative 1 and positive 10. Negative 1 plus 10 is positive 9. Negative 1 times 10 is negative 10. Okay, this is an example of a polynomial, and if I told you to go right ahead and start factoring, you might be noticing that this is not in the same format as the others. Notice all the others I've given you have started with the highest degree term at the beginning, meaning that term with the variable and highest exponent at the front. Well, this time it's at the end. So let's just go ahead and rearrange it so that it is in descending order. Okay, so now we've got it in descending order. However, notice that this is an example of a trinomial that is not a trinomial without a coefficient. The x squared has a coefficient higher than 1 in front of it. It has a 2. Therefore, we, at this moment, cannot use the method that we were just learning about. The reason I have this in here is because as we learn our factoring methods, they do build upon each other. So the first factoring method we learned was the GCF method, where you pulled the greatest common factor out of all of your terms in an expression. When you're factoring, we now have learned the grouping method, which was when we had 4, 6, 8, or more in even increments terms, and we could factor by grouping. Now we're learning the trinomials without a coefficient method. So the reason I'm writing this list is because these methods build upon each other. You won't be done factoring until you have checked off that you've attempted all of these factoring methods. And we should actually always start with the GCF. So first ask yourself, does this polynomial have a GCF before you get going? And if we look at this, each term has a factor of 2 that will divide out of it. So I'm going to factor out the 2 and in an open parentheses leave the remainder from what I've divide it out. Now, you can see that then we would check to see, okay, can we factor by grouping? Now, grouping, if you'll remember, must have at least 4 terms or more. So because what's left in the parentheses is a trinomial, the grouping method is not applicable in this problem. However, with what's left in the trinomial, we now have a trinomial without a coefficient that will factor. So when you do this, you will bring down the GCF you pulled out. You need it with your answer. And now just focus on the x squared plus 5x plus 6, filling in factors of 6 that add up to 5. So factors of 6 that add up to 5, positive 6 are 2 and 3. Both positive, and I'm not able to write for some reason. So we should get, oh, my board's frozen, but we should get 2 times x plus 2 times x plus 3. So there should be an x plus 2 and an x plus 3 in those binomials. My thing froze, but hopefully you heard the answer and know how to fill it out from there. Okay. That will bring us to the end. Let's see if I can. The end of our lesson. Okay, so I did get it to unfreeze and rework this problem so you can visually see what the answer should look like. Okay, we've got a couple more practice problems. I wanted to show you this one really quickly, just because the exponent is a little bit different than what we were seeing on the others. So we still need factors of 6 that add up to positive 5. So factors of 6 would be 2 and 3 that would add up to 5, both positive. Now, remember to find and fill in the first slot. We need to take the square root of that first term, which is an n squared. So I'm going to fill both in with an n squared this time. And this, whatever the exponent, hopefully here you've noticed, whatever the exponent on that variable is, it should match the middle term's exponent. If for any reason it does not, then that is another indication that your trinomial may not factor and it could be prime. But if we did multiply this one back out, you'd get n to the 4th plus 3n squared plus 2n squared plus 6. Those can combine because they're like terms. And there we are. Okay? So we have factored properly, and that's our solution. So that's a way to figure out your middle or your opening positions of the binomials if that exponent's not a squared. Oops, and this is showing. So anyway, this one will be prime. If you're looking at this one, the factors of -2 that would add up to equal a -3 do not exist because we need one to be positive and one to be negative. There are no factors of -2 where a combination one's negative and one's positive that would ever add up to be a -3 no matter how I try this. So we can't find a set of factors, so this one would be prime. Okay, with all of these, I do want you always checking at first, can you factor out a GCF? If you can't, then move down your list of factoring methods. Are there 4 terms or are there 3? If there are 4 terms, you will follow grouping method. If there are only 3, then you can try your trinomial method. There is one last one that I want to show you that will look similar to practice problems you'll see in the homework. In this case, you've got a term at the front that is squared and a term at the end that is squared, and they're different variables. You can still factor this by setting up. It is a trinomial without a coefficient because this one has a coefficient of 1. And look at the numbers kind of in isolation. We want factors of -10 that add up to +3. Okay, so we want factors of -10 that add up to +3. That means one's going to need to be positive and one's going to need to be negative. So the factors of -10 that would add to +3 would be 5 and -2. And so you can go ahead and fill in your signs and your numbers just as normal. The first slot we'll find by doing the square root of that term, a. And to figure out the last slot, we're going to do the same thing in this case. So here you can take the square root of b squared, and that is b, because whatever the last term is, it's the product of these two second slots in the binomials. 5b times negative 2b should give you negative 10b squared. So all you have to do is that same method, take the square root of the b squared. So now you've seen one like that, which will look similar to something you'll see in the homework. And this was just a reminder of the three methods we've now learned and the order in which you should always look for factoring. So today we didn't focus much on the first two. However, that does not mean you ignore these. You should always look for a GCF first, then for grouping before you try this trinomial method. There are whiteboard practice problems through here, so what I'm going to do is just click through these and show that, or reveal the answer so that you can pause, work it out, and see the answer to check your work as you go. So always looking for a GCF first. This problem has one, and I'll leave you with that. You can pause and click play as you need to. So N was the GCF on that one. Two is the GCF there. This one should not have factored. It should have been prime. Okay. This one should have been prime because of the exponent. On the 5, you cannot take the square root of an odd exponent. Well, not cleanly, so we would not be able to find a combination of variables that would multiply back out to give an x to the 5th minus 6 to the x to the 2nd. So this one is prime. Okay, the GCF came out of this one as 3, so it's not prime. However, what's left inside did not go further, so you stop, and this is your final answer. And that is it for our lesson.